Today, I'm going to give you an introduction to programming the PSoC, and by the time we're done today, you should be able to use your PSoC to set the angles of a servo. Before we start today, you should have already installed PSoC Creator. I'll be using PSoC Creator 3.3, but if you have 3.2 or another version, they're similar enough that it should be mostly the same. So once you have PSoC Creator installed, click on File, New, Project. The first thing you need to do here is set the device that you're going to use. Click on Target Device and then click on this drop down and select PSoC 5LP and click Next. Make sure that you select Empty Schematic and not a code example. Now here you have to be careful to give your project a name and save it in a place where you would like it to be accessible in the future. It's kind of difficult to move the location of your projects after you've created them, so make sure that you set it up the way you want it here. Note that right now I have my location set as Google Drive. Sometimes it's very handy to create your project in a cloud folder that will be synced with the cloud, but sometimes they can give you trouble when you're trying to make your project. So I'm going to save this project locally on my hard drive rather than on the cloud, and I recommend that you do the same. You can give your project a workspace name and a project name. A workspace can hold more than one project. So if you want to have multiple programs that you can switch between, sometimes it's nice to have one workspace with multiple projects. So I'm just going to name my workspace EGR 455 Labs. You can call yours whatever you want. And this project I'm going to call Lab 1 LED and Servo. You can call yours whatever you'd like. After you click Finish, you'll have to wait for a moment for it to create the new project. And then you should have a screen that looks like this. In PSoC, there are three main windows that are important to you. The first one is this one called Top Design. This is where you can place modules that you're going to use in your code. Now, find the line on the left that ends with .cydwr and double click. This opens up a window where you can assign the pins on your PSoC. This is the second window that is going to be important to us. The third important window is down here called main.c. Double click there. Here is where you will write your actual code. To give you an introduction to programming in PSoC, we're going to start by writing some code to flash the LED on your PSoC. So go to the Top Design window, and on the right expand the menu called Ports and Pins and find a digital output pin. An LED is digital and it's an output, so we need a digital output pin to control the LED. If the screen is really small, you can zoom in to see what you've done here. Double click on this pin. You can give your pin a different name to be more descriptive than the simple pin 1. So I'm going to call my pin LED. And I'm also going to uncheck the hardware connection. I'm doing this because on my Top Design window, I'm not going to wire the LED to anything. So click OK, and then the little square to the left of the LED goes away, so now I don't have to connect it to anything. Next, go to your CYDWR window, which might be up in a tab here now, and if it's not, you can get there by double-clicking on the CYDWR line on the left. You'll notice that now that we've placed the LED pin, we have a line here that's called LED. And if I click on this drop down by port, I can assign which pin on the PSoC I want this to be. Now if you look very closely at your PSoC, you'll see that there is a little LED on the top of the PSoC, and it's labeled LED1 2.1. This means that that LED that's built into your PSoC is wired internally to pin 2.1. So if we click on this port drop-down list, I want to set my LED to pin 2.1. Now let's go to the main window. Here is where we can write our code. Lines that show up green are comments, and they won't be executed when the code runs. For simplicity, I'm going to start by deleting all of these comment lines. Now, you'll notice that you have a little red X on the left. This is an error in your code. Now, it seems strange that you should have an error before you've run anything. The reason why you have a red X in the very beginning is because we haven't ever built our code yet. When you build the code is compiled to machine code, and the compiler checks for errors. So this first line that says pound include, that's loading up a library of commands, and it doesn't recognize that line because it hasn't yet loaded any libraries. So to get that error to go away, we're going to right away click on build and build whatever you called your project here, Lab 1, LED, and Servo. When you click on build, this window down at the bottom will keep you apprised of the progress of your build. We're going to wait until it says at the end build succeeded or something like that. At least that's what we're going to hope that it says. If it finds any errors during the build, it will let us know in this output window. Okay, so I got a build succeeded, and also the error went away. So we're all good to go now. You'll see that besides the include line on line 1, you also have a function here that is an int function or an integer function called main. It starts here at this bracket and it ends here at this matching bracket. All of the code inside of this int main function will run one time when you either program the PSoC or when you apply power to the PSoC. You also have a loop that is a for loop, and this for loop has no arguments inside of it. Anything that you write inside of this for loop will happen over and over and over again indefinitely when you run your code. This for loop is one way of making an infinite loop, a loop that will never end. I'm going to write some code inside of my infinite for loop that will turn the LED on, wait for 1 second, then turn the LED off and wait for 1 second again. So here's how we write that code. I'll start with the name of my pin, which is LED, and then underscore, and then write, and then in parentheses, if I put a 1 here, it will turn the LED on because it will write the number 1 or a high voltage to the LED. Now, to give a pause in time, I can use the built-in function CYDelay. I can then put a number of milliseconds in the parentheses. So if I want it to wait 1 second, I can do 1000 milliseconds. Then I'll turn the LED off. So we'll do another LED write command, and this time I'm going to write 0. And then I need to wait 1 second so that the LED stays off for 1 second. Because I wrote these lines of code inside the for loop, when the code is finished executing this last line, it will loop back and start again at the first line. So the effect of this code should be that the LED will go on and off for 1 second each indefinitely. The next thing we have to do is plug in our PSoC. Take your USB cable and plug one end of the USB cable into a USB port on your computer. Then take the other end of the USB cable and plug it into your PSoC. When you do that, the lights on the PSoC should turn on. If the lights do not turn on, you might have plugged the PSoC in upside down. Try flipping the PSoC or the cable over and plug it in again. If you're plugging in your PSoC for the very first time, your computer might have to install the drivers. So if when you plug it in, the drivers start to install, just wait for a minute until it says that your device is ready to use. Once it says that your device is ready to use, we need to program the PSoC. We do that by clicking on this little chip that is called Program, or you can also find the program under Debug. You can do Debug Program, or you can click the little chip. You might get a window like this the first time that you plug in a PSoC and try to program it. I'm going to show you how to fix this error if you get this. Click OK. Then go to the Project menu, Device Selector. Here, you need to manually select the specific PSoC that you're using. On your PSoC, if you look very closely above the actual chip on the PSoC, you'll find an alphanumeric code specifying which PSoC you have. For example, my PSoC is a CY8C5888LTI-LP097. I'm going to find that in the list. You'll notice that it's already found a number that's close but not exactly correct. So my number should be nearby here. CY8C5888 LTI-LP097. That's what my PSoC says, so now I'm going to click OK. And then I'm going to try again to program the PSoC. And this time, the program succeeds. At the end, it should say device was successfully programmed, and you should see the blue LED on the top of your PSoC flashing on and off once per second. We can make the LED flash faster or slower by changing the amount of time that we wait while the LED is on and while the LED is off. For example, we could make the LED flash fast by waiting only 100 milliseconds instead of 1,000. Try this and see what the LED does. Now, there's a drawback to this approach to making the LED flash, and that is that while this code is running, we can't get the code to do anything else. Suppose we wanted the LED to flash while we're also, say, running a motor or reading a sensor or something like that. We wouldn't be able to do that because we're using all of our resources to just flash this LED. There's a better way to get the LED to flash all on its own, and once we learn this better way, we can use the same approach to control our servos. Go back to your top design window, and this time let's go to the digital menu and then functions and find the PWM. Click and drag a PWM to your top design window. You'll notice that the PWM window is more complicated than the simple LED pin we placed before. This PWM has multiple inputs and it also has multiple outputs. We need to provide the PWM with a clock input and also a reset input. Let's start with the clock input. Scroll down to the System menu on the right and expand that, and there you'll find a clock. Click and drag the clock, and before you let go of the mouse button, line up the two squares for the clock input and the clock that you've just grabbed and let go. And if you had them lined up correctly, then when you drag this clock away, you'll see that there's a wire connecting your clock to the clock input. If you couldn't get that connection quite right, it'll look like this. You'll have a square there and a square there, and you can connect these two manually by using this wire tool. I click on the wire tool and then I move my cursor on top of the clock output and I click, and then I move the cursor on top of the clock and I click again. I click again, there we go, and it connects the two with a wire. For the reset input, I want to give an input that just tells my PWM to not reset. So scroll up to the top and find the logic menu and find a logic low, and we're going to take that and connect it to the reset. By wiring a 0 to reset, we're telling the PSoC to not reset. Next, let's take a look at the PWM outputs. There are 4 outputs here. The first one, called TC, that stands for timer compare or timer counter. We're not going to use that output at all right now. And the last one is called interrupt. We're also going to ignore that output for now. It's generally okay to leave outputs open and not wired to anything, whereas you usually need to have all inputs wired in order for your block to work. So I'm going to take this LED pin and I want to wire this LED pin to the output of my PWM. In order to do that, I need to get the little square back on my LED. So I'm going to double click on the LED pin and I'm going to check hardware connection and then click OK. So now I have that little square back and I can connect it to the output of my PWM. I can actually wire 2 different things to the output of this PWM and control 2 different LEDs or motors or servos with the same LED block, but for now we're only going to control one, just the LED. Now, to set the settings of my PWM, I'll use the same approach we took to set the settings of the pin. I'm going to double click on the PWM block. Here are the settings for my PWM. You'll see at the top I have 2 plots that are being drawn for me here, PWM1 and PWM2. Those 2 plots correspond to these 2 outputs. These plots are showing me how the pin that's wired to PWM1 and PWM2 is going to be turned on and off. If we want our LED to flash, this process of making it the pin high and low will get the LED to flash. I'm going to start by turning off one of my two outputs. In the PWM mode, I'm going to select one output instead of two outputs. That will simplify things for us a bit since we only have one LED to turn on and off. I'm also going to change the name of this to just be PWM. Since I only have one of them, it will simplify my coding if I don't have a number. Now, a PWM, or pulse width modulated signal, is a signal that simply turns on and off at a regular time interval. In order to control how fast the pulse is being turned on and off, there are only two values that we need to know or that we need to set. One is called the period, and the other is called compare, which is abbreviated here as CMP for compare. The period is the amount of time that passes from the time that the pulse is turned on all the way until the pulse is turned on again. So the amount of time from here to here is the period. The compare value is the amount of time that the pulse is on. So, for example, here the period is on for 255 units. In a moment we'll talk about what these units are. But here the period is 255 and the compare is 127. That's why this pulse string shows the pulse being on for half the time and then off for half the time, because the compare value is half the period. So, for example, if we wanted the pulse to be on for only 1/4 of the whole time, I could set the period to be 200, and I could set the compare value to be 50. Then, since the compare is 1/4 the period, the pulse string will be on for 1/4 of the amount of time. It's off for 150 time units, and it's on for only 50. So let's suppose that we want to use this PWM to replicate the flashing pattern that we have going on the LED right now. Right now, the LED is on for 100 milliseconds and off for 100 milliseconds. How could we set the period and compare value to achieve a flashing pattern of 100 milliseconds on and 100 milliseconds off? In order to figure that out, we have to understand what the units are of these numbers in the period and compare value. The units we find out by looking at the clock that we've wired to the PWM. Here, our clock has these little letters underneath it that says 12 megahertz. This means that our clock is going to tick 12 million times every second. The units on the period and compare value are units of ticks of the clock. So our clock ticks 12 million times per second, and I would like to know how many ticks will be 100 milliseconds. All I have to do here is a simple unit conversion. $1.2 million ticks corresponds to 100 milliseconds, or 0.1 seconds. I want my compare value to be 100 milliseconds. So let me try and put 1,200,000 ticks. I get an error. The problem here is that we've set up this PWM to be an 8-bit PWM. That means that our period and compare value can both be no greater than 255. Because 255 is the largest number that you can represent with 8 bits. One thing we could do is we could change this to be 16 bits. With 16 bits, we could represent a number as big as 65,535. But that's still not big enough to let us do our 1.2 million number. So how could we solve this problem? One thing we can do is we can slow down the clock. Let's do that. I'm going to set this compare value to a number that it will accept, like maybe 10, and then I'll click OK. Now, here in my clock, I'm going to double click it, and I'm going to change the frequency of the clock. So what value should I set for the new speed of the clock? I need to be able to time 100 milliseconds for my compare value, and I also need to be able to time 200 milliseconds for my period value. Let's do a simple calculation to figure out approximately what the clock speed would need to be to allow this timing. Over in my calculation, I'm going to take the clock speed and make that a variable. I'll just represent it with the letter C for clock. Clock ticks per second times 100 milliseconds. Let's make this 200 because that's the largest number. We need that to be our period. Times 1 second per 1,000 milliseconds. That will give us some number of ticks. We need to make sure that this number of ticks is no greater than about 65,000, which is approximately the largest number we can represent with a 16-bit value. Now, let's solve this equation for C. When we solve this equation for C, we get 325,000 ticks per second. Let's put that into our clock speed. Right now, our clock speed is set as megahertz. Mega is for million. Let's click on the drop down and change this to kilohertz. And then for the frequency value, we'll put 325. 325 kilohertz means that the clock will be ticking 325,000 ticks per second, which is what we calculated. So I'll click OK. The number is updated in my clock, and now I'm going to go back into the settings for the PWM. From our calculation that we just did, we calculated that we would get 200 milliseconds with 65,000 ticks. So I'll put 65,000 in for the period, and you'll see that it calculates for me the amount of time for the period as approximately 200 milliseconds. It's off by a little bit, but it's close enough for what we need. Now, what should we set for the compare value in order for the pulse to be on for 100 milliseconds? We can go back to our calculation and plug in 100 milliseconds for the time, and using 325,000 ticks per second, we find that the compare value should be half of the period. We can look at our pulse string to check and see if everything looks right. It certainly looks like it's on for about half the time. So let's click OK. Now all we have to do is finish up our code. Our pin is already assigned to the LED. If we go into the main.c, we have to make a few changes here. First of all, we no longer need to turn the pin on and off. The PWM signal is doing that for us. In fact, what we have to put here is very simple. All we have to put here is a line to turn on the PWM module. I'll do PWM start, open and close parentheses, and a semicolon. You'll notice that we get a warning here. That's because we've placed the PWM in our top design, but we have not yet built the code. So this is similar to how we got an error on the include line when we first created our code. The PSoC creator compiler does not yet know that PWM start exists. So let's go ahead and build the code to check and make sure that this warning goes away. If your build succeeded, go ahead and click on the Program button, and you should notice that the LED on the PSoC continues to flash the same way it did before. So let's try and make it flash at a different rate to see if our PWM is working the way we expect it to. One of the powerful aspects of using PWM for our timing is that we can change the period and the compare value in our code. Let's try and make the LED flash at a couple different rates. In the for loop, let's do PWM write compare, and now in the parentheses we can put a new value for the compare value for our PWM. Right now the compare value is set as 32,500. Let's change between that value and a value that is half as much. So let's do 32,500, and then we'll wait for, let's say, 5 seconds. Then let's change the compare value to half that amount. And wait another 5 seconds. Program the PSoC and watch the flashing of the light. Right now, it doesn't look that much different because we haven't changed the period value. Let's try and change the period at the same time. Now you should see the LED flashing relatively slowly for about 5 seconds, and then twice as fast for 5 seconds. Once you've got that, we're going to move on and start to try to apply what we just learned to setting the angles of servos. From your robotics kit, find a servo horn, and 3 jumper wires. My servo horn is colored red so that you can see it better in the video. Yours will be clear. The first thing I'm going to do is press this servo horn onto the servo. Now I'm going to do this very carefully. The horn goes on one way much easier than the other way. So if you're trying to press the servo horn onto the servo and it's going on really hard, just pull the servo horn off, flip it over, and press it on the other way. There we go. Having the servo horn on will help us to see what angle the servo is at better. Now, the servo angle is set by giving a PWM signal to the orange wire of the servo. The brown wire is for ground and the red wire is for power. The orange wire is a PWM signal that sets the angle of the servo. Now we know approximately what values to set for the compare and period in order to change the angle of the servo. Our period has to be approximately equal to 20 milliseconds. I get this from the data sheet of the servo. Some servos are different than others. You can always find out this information from the data sheet. Most servos have the same communication protocol, which is a period of 20 milliseconds. Then the angle of the servo will rotate approximately 180 degrees while changing the compare value between about 0.75 and 2.25 milliseconds. Those are approximate numbers. So what we want to do to get our servo turning to different angles is first we need to figure out what to set the period value to in order to get 20 milliseconds. And then we want to write some code to change the compare value between 0.75 and 2.25 milliseconds. Then we're going to wire up our servo. I'm going to show you right now how to wire up the servo. We're going to take one jumper wire, plug it into the brown wire of the servo, and on the PSoC you're going to find a pin that's labeled GND. There's one, put my hand over the LED here, there's one GND down here at the end. I'm going to plug in GND there. Then I'm going to connect a jumper wire to the red wire. This is for power, and power from your PSoC is provided on a pin called VDD. There's one down here. Then the signal, your PWM signal, goes to the orange wire, and I'm going to connect that to pin 07 just because it's close to the other ones. Now once you have that wired up, we're going to go back into our code and we're going to go to the CYDWR window, and I'm going to change this pin to be 07. Now what I want you to do is change this code where we're setting the compare and the period value, and try and set these two values so that the compare ends up being 0.75 milliseconds here, and the compare value ends up being 2.25 milliseconds here. Now we're going to take these right period lines and I'm going to delete them because we don't need them for this activity. You'll need to change these two numbers here in the code, and then when we go back to the top design, you're going to need to change the clock speed and the period value here so that the period ends up being 20 milliseconds, and so that the compare values here end up being 0.75 and 2.25 milliseconds. When you get this right and you program the PSoC, your servo will move from approximately 0 degrees to approximately 180 degrees and stay in each position for 5 seconds. That's your task to accomplish today in lab. And once you have that accomplished, call me over and I'll check you off for having completed this lab.